Good morning, everybody. Welcome to a sunny morning of Chem 1105 with your host, me, Dr. White. All right, we're going to have a wonderful morning. Uh, Today, we're going to do some practice. Practice is good for your grade. Also, I get what I want. You'll learn chemistry, and then we'll do our lab. All right, let's get to work. All right, I have on the screen, thumbs up people, do you see important information? Test two. Thank you. And this is important information. In the past, students had to memorize this. And today, what I'd like to do is go through and practice this and this and this. And you should know 1 mole of a compound equals the molecular weight of that compound in grams. 1 mole of a compound equals the molecular weight of that compound in grams. And the molecular weight of a compound is the sum of all atomic weights. And remember on the periodic table, which, oh no, I don't have one opened up. Hold on. Or don't hold on. And the periodic table, you should see momentarily. Remember on test 2, 3, 4, and the final, it will say, please use all atomic weights to 3 significant figures. And what does that mean? If you look at carbon, 12.011, round that off to 3 significant figures. Your turn. And the answer is 12.0. Keep the 1, keep the 2, keep the 0. Use this one to round off. It's 4 or less. Drop that. And the other one, 12.0. Let's look at hydrogen. Round that off to 3 significant figures. Time's up. Keep the 1, keep the 0, keep the 0. Use the 8 to round off. That's 5 or higher. I'm going to drop that, and the number in front, I'll increase by 1. So to 3 significant figures, the atomic weight of hydrogen is 1.01. And that's something you should practice. Now, let's have some fun. Let's have the right color. And the question is, how many grams of methane are 2.051 moles of methane, CH4? By the way, methane also has another name. You know that as natural gas. And that's the stuff your house is heated with, your apartment, your condo, your water heater for most people in Northern Illinois. And also, if you cook with gas in your house, or your parents cook with that, or your friends do, you're using methane. Now, we just went through the atomic weights for carbon is 12.0, and for hydrogen is 1.01. And I'm going to let you try this all by yourself. So go ahead. And what is the how many grams methane are 2.057 moles of methane? Your turn. If you don't have a calculator, just set it up. And I'm going to do something real quick that I forgot to do. Now I did that, pinned myself, ouch. Remember, 1 mole of a compound equals the molecular weight of that compound, and the molecular weight is the sum of all atomic weights. I really should have some music like game show music to play while you're working on problems. You know, no, I'm not going to hum any. It'll ruin your day. It'll ruin my day if I hum game show music, like The Price is Right, which I haven't looked at in I don't know how many decades, or all the others. I was never big into those. All right, I think everybody's just about done. I'll give you another 20 seconds. Go. Well, I think that was more than 20 seconds. So time for Dr. White to get to work. All right, look at the problem. First thing you should answer is, what are you being asked to find? And you're being asked to find how many grams of methane, CH4. And what are you given? 2.057 moles of methane, CH4. And you also have a periodic table, which you'll need later, the atomic weights of carbon and hydrogen. So the only thing I have to work with is this number, so I will. Now, what units do I want my answer to be? And we took the time to figure that out, and that's grams of methane. Now, if I had a ratio that I could multiply this to get 2 grams of methane, what would that be? Well, how do you figure that out? Well, you use your good buddy, your good friend, unit analysis. I love that whistle. If anybody doesn't like it, send me an email to remind me to give you a warning. Cover your ears. And unit analysis, whatever I'm trying to get to, goes on top of the ratio. Whatever I'm trying to get rid of goes underneath the ratio. And now I'll write those units in. And where do I get these numbers? From the fact that 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight of that compound is the sum of all atomic weights. So I need the molecular weight of methane. There's 4 hydrogens, and the molecular weight I'm going to do right here, and there's 1 carbon. Each hydrogen has atomic weight of 1.01. Each carbon, there's only 1, has atomic weight to 3 significant figures of 12.0. Do the math, multiply, and now we'll add, because they're the sum of all atomic weights, and we get 16.04. Now, when you're adding, you get the same number of significant figures to the right of the decimal in your answer as the number that has the fewest significant figures. This has 2, this has 1. Which is the lower number? Hopefully I'll pick 1. So how do you round this off? Here's my decimal, keep the 0, use the 4 to round off. Is that 4 or less? And the answer is yes, so I'm going to drop it. So the molecular weight of methane, C4H8, is 16.0. So for every 1 mole of methane, there's 16.0 grams. And now before I pick up my calculator, I'm going to do 2 things. 1, notice moles divided by moles. Anything divided by itself equals the number 1. Cancel out. And then this is 4 significant figures. 1 is an exact number. It's the definition of what 1 mole is. And this is 3 significant figures. So my answer should be 3 significant figures, because when you multiply and divide, the number that has the number that you're multiplying and dividing that has the fewest significant figures is how many significant figures your answer should have. And now I'm going to pick up my calculator, turn it on, clear it. And my calculator gives me this number. And if you put that down, I'm going to take off a point, because that's not 3 significant figures. I'm going to let you try and round that off to 3 significant figures, and I'll give you 6 seconds. Go. Time's up. Keep the 3, keep the 2, keep the 9. That's my 3 significant figures. Use the 1 to round off. That's 4 or less. I'll drop it. So the correct answer for this is this. All right, let's continue. Now, the question is, how many moles of water are 1.265 times 10 to the fourth grams of water. Now, what you'll need, the atomic weights, which you should know how to do on the periodic table. For hydrogen is 1.01. For oxygen is 16.0. And time for you to work. Get to work. No, that's not polite. Please start. Get to work. And while you're working, a public service announcement from Dr. White. Don't forget today, hand in the lab that's due today, because starting today, I will be enforcing what's in my syllabus. If you're late today and less than 8 days late, I'm only going to take off 2 points. If you're more than 8 days late, you'll get a 0. Don't forget about my amnesty program. If you haven't handed in some labs, if you can't get to the link, email them to me. If you need the labs, email me and I'll send you copies of them. And also don't forget, I'll stay after lab today if you have any questions, and I'll also have my office hour. Oh, I just forgot something. You keep on working. I will be right back. I'm back. All right, I think everybody's done. So let's do this. First thing, when you see and relax, take a deep breath. This is called a word problem because it's made up of words and numbers. And the question is, first of all, what are you being asked to find? how many moles water? And what are you given? This. And therefore, hold on one sec. Running out of room. I did something I shouldn't have done. I started at the end of my whiteboard. And therefore, the only number we have to start with is this. And what units do I want my answer to be? Well, we took the time to figure that out. And that's moles of water. And now use my good buddy, my good friend, and has been for many, many years, unit analysis. Whatever I'm trying to get to goes on top of the ratio. Whatever I'm trying to get rid of goes underneath. And now I'm going to write those units in. And where do I get these numbers? In case you forgot, this will be available to you. Important information, test number 2. 1 mole of a compound equals the molecular weight of that compound in grams. And then the molecular weight of that compound is the sum of all atomic weights in that compound. So let's get back to our work. We need to get the molecular weight of water. And that's the sum of all atomic weights. Water has 2 hydrogen and 1 oxygen. Each hydrogen has atomic weight to 3 significant figures, 1.01. The oxygen has atomic weight to 3 significant figures, 16.0. 2 times 101 is this. 1 times 16.0 is this. Remember, 1 and 2 are exact numbers. And now we'll add it up and we get 18.02. Now, when you're adding up, you have the same number of significant figures to the right of the decimal as the number that has the fewest. This has 2, this has 1. Which is a lower number? Hopefully I'll pick 1. Therefore, here's my decimal. Keep the 0, use the 2 to round off, that's 4 or less. So the atomic molecular weight of water is 18.0. Therefore, for every 1 mole of water, I have 18.0 grams of water. Now, before I pick up my calculator, notice grams of water divided by grams of water, anything divided by itself equals 1. So this cancels out, and I'm left with the right units, which is a good thing. And know that this is 4 significant figures. This is 3 significant figures. This is an exact number. And on test number 2, like test 1, it will say underneath their name, please use proper significant figures for all calculated answers. If you don't, I'll take off a point. If you don't do enough of them, you're going to not do good on test 2. So let me put in 1.265 double E 4 divided by 18.0. And my calculator, and I'm going to move it down here, gives me this number. There are a few more sevens I have, but I'm not going to write them down. And I'll let you round that off to 3 significant figures. All right, now I'll do it. Keep the 7, keep the 0, keep the 2. Use this 7 to round off. Is that 4 or less or 5 or higher? It's 5 or higher. So that and everything else, when you're past the decimal, which we are, I drop and I increase the number in front by 1. So the correct answer is 7.03 times 10 squared moles of water. Now, important public service announcement, show your work. What if you didn't show any work and you put down, you say 8.02 times 10 to the squared, and you didn't show any work? You're going to get 0 points. If you show all this work and you make a mistake like add something wrong here or put in the wrong number there, if you show your work, I'll only take off 1 point for a math error. And now it's time for show and tell from Dr. White. I promised I'd do this earlier, but I didn't, but I'll do it. This is a calculator. They're now cheap. Back when I was in high school and college, we didn't have calculators. I think it wasn't until grad school, I think my second year or third year, that HP started selling calculators, and they were $500 a piece, which in today's dollars would be a couple $1,000s for a calculator. One grad student bought one. We were all, ooh, can I touch it? But what did you use if you didn't have a calculator? This. What's this? Oh, let's open it up. By the way, this is one of my prized possessions. This is called the slide rule. Why? Because it slides. And this was my graduation gift from my parents, which was a very fine graduation gift. These were quite expensive. I think this cost $50, which in today's money would be a couple $100. And plus, this was really fancy of the day. If you notice, it has Teflon tracks right here, and it's made out of bamboo here, so it doesn't stick. And with a slide rule, you can multiply and divide and do other math functions like logarithms, power of 10, and everything. And this is what got me through undergrad and grad school. And this is my good friend, my good buddy too. And this is a slide rule. Now, the interesting thing about a slide rule, which I still do to this day, and most of my generation do, you can only get 3 significant figures on a slide rule. So if you notice a lot of things, and that's why atomic weights, I use the 3 significant figures. So say hello to my old friend, the slide rule. If you notice, I even have my name on there when I was in. And I have my parents' phone number inside. This was really top-notch slide rule and served me well. All right, now that I've gone down memory lane with you, it's time to get back to work. Now here we have a balanced chemical equation. All right, hopefully you all see this. And the problem is how many moles, excuse me, of chlorine gas, Cl2, are needed to react with an excess of sodium to make 8.111 moles of sodium chloride. And this one I'll do. I'm going to give you one to try too. So what are we trying to find? How many moles chlorine gas? And that's Cl2, not Cl, chlorine atoms. And we're given an excess of sodium. As soon as you see excess, you can ignore it. But we are given 8.111 moles of sodium chloride. So the question is, what do we do? Well, this is the only number I have to start with. Oh, by the way, don't forget, if you ever go out in a restaurant with me or any other chemist, we're going to say, please pass the NaCl, meaning the table salt. This is the formula for table salt, or you know it as salt. This is what we have. What units do we want our answer to be? And the answer is moles of chlorine. And if we had a ratio to convert moles of chlorine to moles of sodium chloride to moles of chlorine, how would we proceed? Use your good buddy, your good friend, unit analysis. Whatever we're trying to get to goes on top. Whatever we're trying to get rid of goes underneath. And now I'll write those in. And where do we get a relationship between moles of one compound and moles of another? We look at the balanced chemical equation, and the coefficients give us molar relationships. What this really means are 2 moles of sodium react with 1 mole of chlorine gas, Cl2, to make 2 moles of sodium chloride. Please pass the NaCl. Remember, the coefficients, the number in front, give you molar relationships. And if there's no number, like in front of Cl2, it's the number 1. And therefore, we can see that for every 1 mole of chlorine, Cl2, you make 2 moles of sodium chloride. So for every 1 mole of chlorine, we make 2 moles of sodium chloride. And now, before I pick up my calculator, notice moles of sodium chloride divided by moles of sodium chloride. Anything divided by itself equals number 1. Anybody having nightmares having me write A divided by A equals 1? I hope not. Anyways, this cancels out, and we're left with moles of chlorine, Cl2, which is what we want. Now, remember, the coefficients of a balanced chemical equation are exact numbers. So let's continue. And because of that, this is 4 significant figures. Our answer will be 4 significant figures. So I'll take 8.111 and divide that by 2. And my calculator gives me the following answer. And now I'm going to let you round that off to 4 significant figures, and then I will. Time's up. Keep the 4, keep the 0, because that's a decimal point. All zeros after decimal point, also it's confined, are significant. Keep the 5, keep the 5. That's our 4 significant figures. And we use this number to round off. Is that 5 or higher? It's a 5, so it's 5 or higher. Drop that, increase this by 1. So the correct answer is 4.056 moles of chlorine. And that's how you do it. Remember, the coefficients of a balanced chemical equation are molar ratios. This says 2 moles of sodium react with, since there's no number, it's 1 mole of chlorine to make 2 moles of sodium chloride. And now I'm going to let you have some fun. Dr. White shares the fun, and that is how many moles of water are made if you react 7.5 moles of O2 with an excess of hydrogen. Your turn. And don't forget, tomorrow is turn on your webcam day for Dr. White, please. Boy, nobody has their webcam on. Not one person. Well, I do, but none of you. Come on, turn it on so I can see there are real people out there, not just names. Oh, well, thank you, Spencer. Don't worry if you don't have a webcam. For those who are interested, I'm using a Logitech. The model, I forgot the name, but it's about $100. I actually have 2 of them. When they were in rare supply, I was able to get this one from App. And then I also got a backup through Amazon when they're in more supply. And it's been quite useful during the pandemic. That's an understatement of the year. Normally, if we were face to face, I'd say, when you're done, look up and smile. And I can look at the students and tell when they're done. And if you finish early, please be patient. I want to give everybody time to try this. All right, let's get to work. So the first thing you should answer is, what are you being asked to find? How many moles of water? And then, what are you given? Well, you're given 7.5 moles of O2, oxygen gas. Whenever you see excess of something, in this case hydrogen, you can ignore it. And you also are given a balanced chemical equation. So how do we proceed? Well, this is the only number I have, so I'm going to start with that. And if I had a ratio, that I could multiply this by, what units do I want my answer to be? Well, we took the time to figure that out. And now use my good buddy, and hopefully it'll be yours too, good friend, unit analysis. Whatever I'm trying to get to goes on top of the ratio. Whatever I'm trying to get rid of goes underneath. I'll write those units in. And where do I get a relationship between moles of water and moles of oxygen? From the balanced chemical equation. And remember, the coefficients, the number in front of the formulas for different molecules or elements, give you molar relationships. This is 2 moles of hydrogen react with 1 mole. When there's no number, it's 1 oxygen to make 2 moles of water. So now I know that for every 1 mole of oxygen, I make 2 moles of water. So I now have that. Before I pick up my calculator, notice moles of oxygen divided by moles of oxygen cancel out, because anything divided by itself equals the number 1, cancels out. And now I look, this is, I threw a curveball at you. This is 2 significant figures. And our answer should be 2 significant figures. If I do the multiplication, let's see what my calculator does with this. Now, it gives me 15. And I'm done, because that's 2 significant figures. Actually, it also gave me 1.5 times 10 to the 1. And that's also 2 significant figures. And either answer would be correct. And that's important things I wanted to practice. We're not done yet. But if I look at the time, I think this would be a good time to take a break. Come back at, let me look at my clock, 9:51. I'm going to take a break. I'll see you in 5 minutes. I'm going to get up and stretch. Be back in 5. Let's get going. Oh, wait, let's do a better whistle. Trains leaving the station, all aboard. All right, let's continue on. Yeah, hopefully everybody's back. What the following? And let me read the problem. And I'm going to do this one. How many grams of water are made when you react 45.2 grams of O2, oxygen gas, with an excess of hydrogen gas, H2? So what are we being asked to find? How many grams of water? What are we given? 45.2 grams of oxygen gas. We're also given the balanced chemical equation. And when you see excess of something, you can ignore it. Now, if you notice, I start out with grams of oxygen. I want to get the grams of water. There is no way you can do that in one step. There's no way you can do that in one step. You need 3 steps. And where do you find those 3 steps? If you look at important information, we have the 3 steps. 1, 2, 3. And this is mass calculation. Whenever you see mass, think of grams. You convert the mass of whatever you're given to the moles of what you started with A. Then you've now calculated moles of A. You convert that to moles of what you're trying to get to molecule-wise. And finally, the third step, now that you've calculated moles of B, you convert it to mass grams of B. If you think about what we've just done this morning, we've practiced those 3 steps individually. I did that on purpose. See how sneaky I am? So let's get to work. Step 1. What does it mean, mass of A to moles of A? Well, whatever you're given initially a weight, which in this case is oxygen, I want to convert to moles of A, which in this case is oxygen. And we just practiced that, but let's do it again. Use your good buddy, your good friend, unit analysis, whatever we're trying to get to, the units go on top. Whatever we're trying to get rid of, the units go underneath. And where do we get a relationship of moles of O2 to grams of O2? Well, you look at important information. Test number two, wrong test. Test number two, 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight of that compound is the sum of all atomic weights. Well, I have to find the molecular weight of oxygen. And the molecular weight, which I'll abbreviate MW, of oxygen is the sum of all atomic weights. There's 2 oxygen atoms. Each oxygen atom, the 3 significant figures, has an atomic weight of 16.0, which is 32.0. So for every 1 mole of oxygen gas, you have 32.0 grams of oxygen. And notice grams of oxygen divided by grams of oxygen cancel out, because A divided by A equals 1. This is 3 significant figures. And this is 3 significant figures. And now I'll pick up my calculator, because I know I'm going to get moles of oxygen. And the number I get, and I'm going to round it off, is 1.41. Now, before I continue, there's something I should mention. When you have multiple calculations for a problem like this does, 3 steps, there's 2 philosophies in rounding off. One is round off at each step that I like, and the other is wait until the end and round off. Look at all the numbers and round it off that way. Now, for my test and final, I will calculate both ways. Most of the time, they're the same number, but sometimes they're different. And if you do either way, I'll calculate it, and either answer, if they're different, will be correct. However, on problems in class, I will do round off at each step, because that's worked for me all my life, and also because of my slide rule. You met my slide rule. All right, now, are we done? No, we're trying to get the grams of water. Now we need step number 2, which is moles of A to moles of B. And what does that mean? Well, moles of A is what we started with, oxygen, which we now have. So I'm going to write that down. And I want to convert it using a relationship ratio to moles of B. What's B? What we're trying to get to. In this case, water, not grams, moles. And now I'll use my good buddy, my good friend, unit analysis. Whatever I'm trying to get to goes on top of the ratio. Whatever I'm trying to get rid of goes underneath. And I'll write those numbers in, or not numbers, words, units. And where do I get those numbers? I come up to my balanced chemical equation. And the coefficients, the number in front, give me molar ratios or relationships. And that really means there's 2 moles of hydrogen. When there's no number, it's 1. React with 1 mole of oxygen to make 2 moles of water. And if I come down here, for every 1 mole of oxygen, I make 2 moles of water. And again, the relationship between moles of oxygen and moles of water is right there. Remember, these are exact numbers. Therefore, this is 3 significant figures. Now you know why Dr. White loves three significant figures, because of my slide rule, three significant figures. And I'll pick up my calculator and I'll multiply 1.41 times 2, and I get 2.82, which is three significant figures. Am I done? And the answer is no. How do I know? Because I took the time to figure out, that's why I like to put a question mark, I'm trying to get the grams of water. And now we'll have to do step number 3. That's moles of B to grams of B. And what's B? What we're trying to get to, this case, 2.82 moles of water. And we're trying to get to grams of B, which in this case, B is water. And again, I'll use my good buddy, my good friend, unit analysis. Whatever I'm trying to get to goes on top of this ratio. Whatever I'm trying to get rid of goes underneath. Anybody guess my favorite color? Look at the arrow. And I'll draw that in. And we have grams of water on top, moles water underneath. Where do I get the numbers that go here? We look at important information, test number 2, in case you forgot. And mole, 1 mole of compound equals the molecular weight of that compound in grams. And the molecular weight of the compound is the sum of all atomic weights of that compound. So I need, for every 1 mole of water, I need right here the molecular weight of water in grams. And water has 2 hydrogens, 1 oxygen. We've done this before, so I'm going to zoom through it. Add it up. Remember, when you add, you get the same number of significant figures to the right of the decimal as the number you're adding. That has the fewest. This has 2. This has 1. 1 is the fewest. Keep the 0. Use 2 to round off, 4 or less. So it's 18.0 grams. And now notice moles of water divided by moles of water cancel out, because anything divided by itself equals the number 1. And now I can pick up my calculator. And the number my calculator gives me is this. And if you put that down, I'm going to take off a point, because this is 3 significant figures. This is 3 significant figures. And this is an exact number, which doesn't play a role in the calculation. When you multiply and divide, the numbers you're multiplying and divided, your answer has the same number of significant figures as the number that has the fewest significant figures. In this case, 3. So I'm going to let you round this off to 3 significant figures. Well, I have some tea. Uh-oh, I'm out of tea. Water, back up. And now, how do you do it? Keep the 5, keep the 0, keep the 7. Use the 6 to round off. It's 5 or higher. Drop that, increase that by 1, 5.08 times 10 to the first grams of water. And that's how you do it. Now, I'd highly recommend everybody do the practice problems, chapter 5, part 1, because 10 points. 10 points. Hint, hint, wink, wink, hint, hint, say no more. That comes from Monty Python Flying Circus. If you've never seen Monty Python Flying Circus, find it. It's one of the funniest TV shows that's ever been on TV, period. All right, it's time for lab. Are you ready for a lab, everybody? Yes, I hope you are. All right, today's lab is not that. It's balanced chemical equations. Thumbs up, people. Do you see balancing chemical equations on your screen? Thank you, Elena. She was the first. All right, now, for this lab, you're going to balance chemical equations on the next 2 pages and submit the balanced chemical equations to the assignment area Blackboard by next Tuesday, end of the day. Now, there are important things I'd like to remind you. And this one is one of the most important. And remember, when you're balancing chemical equations, you should have the same number of atoms of each type on each side of this arrow. Remember, at the base of the arrow, these are the reactants. At the head of the arrow, this is the products or products. Now, to balance it, well, I have 2 hydrogen here, I have 2 hydrogen here, but I have 1 oxygen, I have 2 here. So you can't change the formula, but you can change the coefficient. So now I have 4 hydrogen on this side and 2 oxygen. Well, I have 2 oxygen, but I need 4 hydrogen, and I'll put a 2 there. And now I have 4 hydrogen. 4 hydrogen, 4 hydrogen, 2 oxygen, 2 oxygen. And now it's balanced. Now, something very important that's part of balancing chemical equations. I could have also written this. If you notice, 8 hydrogen, 4 oxygen, 4 oxygen. And you could say that's balanced. And the answer is no, this is wrong. Well, why is it wrong? If you can divide all the coefficients by the same number and get whole numbers, if you can divide all the coefficients by the same number and get whole numbers, you should. It's always the lowest ratios. And that's why, notice if I divide each of these by 2, I will get that. And this is an important consideration. I see students do that, and I will mark it wrong because it is wrong. It even says it on the screen. Can you keep a secret? On test 2, when I write it historically, and I will, I usually have 3 or 4, usually 4 balanced chemical equations that you have to do for test 2. Each one is 3 points. So this is an important skill, 12 points worth on test 2. And therefore, I highly recommend you learn how to balance chemical equations. Now, one of the important pieces of advice that I gave you in the past is always do carbon, hydrogen, and oxygen last. And why don't you try this one? Balance that chemical equation. I'm going to let you have some fun. Remember, you should be balancing that chemical equation. All right, I think everybody's done. So how do you balance this? Well, I'm going to follow my own advice since it's worked for me for many, many years. Do hydrogen oxygen last. Oh, I've got 5 carbons here. I only have 1 here. How do I get a 5? I changed the coefficient. So now I have 5 carbons. Since I'm going this way, well, I only have hydrogen and oxygen left. So I'll do 12 hydrogen. How do I get, oh, I only have 2 here. Remember, you can't change the chemical formula, but you can change the coefficient. And 6 times 2 is 12. And finally, oxygen. Well, I've got 2 here, but how many oxygen on this side? You count all the oxygen atoms. 5 times 2 is 10 oxygen atoms plus 6 times 1. Add them together, and that's 16 oxygen. Well, how do I get 16 oxygen here? You can't change this number. Students do. It's always going to be wrong, but you can change the coefficient. And 2 goes into 16 8 times. So let's check. 5 carbons, 5 carbons, 12 hydrogen, 12 hydrogen, 16 oxygen, 16 oxygen. And now it's balanced. 1 molecular mole of, this is called pentane. That's the organic chemical name for this, which I'll never ask on a test, plus 8 moles or molecules of oxygen, make 5 molecules or moles of CO2, carbon dioxide, plus 6 molecules of water. This is called combustion. And this is what happens in your car engine if you have a gasoline car. Battery car, no, but gasoline. And notice you make, when you burn gasoline, and gasoline has some pentane and other, these are called hydrocarbons, makes CO2 and water. I remember years ago, I was up early and out driving, and it was like 5 below, real cold outside. And I come up to a stoplight, I look in the car in front of me, I can see the tailpipe, and I see liquid coming out of the tailpipe. And for about, took me almost 2 seconds. Oh, come on, you know better. Oh no, the car's leaking gasoline. No, it's not. Coming out of the tailpipe, if your engine is tuned properly and you have a catalytic converter, is CO2, which is a colorless gas at room temperature, and water. Now that tailpipe and your muffler get real hot. And therefore, the water that comes from your engine becomes a gas. Remember, liquid to gas. And you don't see it. You don't see water vapor, But if you start out, if a car's starting out in super cold weather, the muffler is still cold enough that it condenses, turns the gas coming from your engine of water into a liquid. And that's what you see. Bet you never thought all the neat things you learned from Dr. White. Now, this is iron. This is ferric oxide. You also know it as rust. And I'll do this one because I want to teach you what I call even, odd. Now, I call it a trick. Really, it's a methodology that sounds more scientific. And how do we do this? There's no way I can multiply a whole number. Remember, the coefficients are always whole number times 2 to get 3 oxygen. There's no way I can multiply a whole number times 3 to get 2 oxygen. So what do? Well, you multiply the two numbers together, that's 6. 2 goes into 6 3 times. So I have 6 oxygen here. And what do I multiply this to get 6? 2 times 3 is 6. Well, now they're balanced oxygen-wise, but now I have 4 iron. And how do I get 4 iron here? That. And now let's check if I'm done. 4 iron, 6 oxygen, 6 oxygen. And that's the even odd trick. Remember, these are your friends. They've been my friends. When you're doing a chemical, balancing a chemical reaction, leave hydrogen, oxygen last. You don't have to, but it makes your life so much easier. I don't know about you, but I like my life being easier. And then for even odd, when you have an atom on one side that's even in the formula and odd on the other, you do the even odd. I call it a trick, but let's call it methodology. It sounds more scientific. Now, for today's lab, you'll be balancing all these chemical equations. Now, one thing I want to point out, there's a question right here that students forget. And if you forget it, I'm going to take off a point and ask, what's the sum of the coefficients in the balanced chemical equation for I? That's 1I. And do that. Now, next page, I have more balance equations for you to balance. And next week, you'll be handing this in. Remember, labs are 10 points. Now, one of the things that I won't do on a test, but I did in that lab, one or more might be balanced. So if it's already balanced, put it down balanced. However, on a test and a final, hint, hint, if I ask you to balance a chemical equation, you'll need to balance it. And with that, I'm done for today. I'll stick around if you have any questions, or for those of you who don't know how to use this with scientific notation, stick around and ask me. I'll show you how to do that again. Other than that, I'll say, Gang gesund, goodbye, but don't forget, wear your mask out there, like that one, or the others I have, not mine, but yours. And don't forget, get the vaccination if you haven't. Hopefully in a couple of weeks, I'll be getting my booster shot. Yes, don't tell anybody, but I'm over 65 if you haven't figured that out. Yeah, oh, I shouldn't have said that. Well, anyways, Gang gesund, goodbye. I'll see you tomorrow morning. Bye.